Thank you, and GM. I'm Savio from the Noir team at Aztec. Before we jump into the sharing itself, let's do a show of hands just to warm things up. Is there anyone from the crowd that is interested or has had the urge to learn about zk development? Can I see your hands? Cool. Is there anyone from the crowd that has actually had the experience of developing in zk? Can I see your hands? Awesome. Is there anyone from the crowd that is happy and satisfied with their zk development tech stack? Can I see your hands? Interesting. Cool. Today in this session, I'll be diving a bit deeper on Noir, the zk language, bringing you guys through it. We will be treading things pretty lightly, so hopefully it will be helpful as well as enjoyable to you guys. Just a quick rundown of today's sharing. We'll be first covering an overview of the language itself, then a bit on the features of the tech stack that the language offers, a quick glimpse into the project landscape of Noir, then on some things that we might be interested to keep an eye out for in the Noir land. But to starting things off, just to make sure we are on the same page, syncing up, we all know zk proofs are powerful, both for shielding information. Zcash as one of the pioneers using zk to enable private transactions. Dark Forest, if you are familiar with the game, uses zk to hide away planet information, planet coordinates within the game while on a public chain. And zk proofs are also powerful in compressing computations. So zk-sync or other layer 2s, zk rollups specifically uses zk to compress state transitions between old states and new states. Axiom, if you're familiar with the project, uses zk proofs to compress the retrieval of historic Ethereum data, etc., etc. So zk proofs are powerful for two main features, but developing in zk has been hard. It often requires an advanced degree of knowledge in cryptography, as well as manually crafting your circuits, manually crafting your code. And despite perhaps not intended, but zk development has been pretty walled in terms of development. It's often tied, the tooling is often tied to, say, specific proving backends, as well as tied to maybe ecosystems or specific chains, depending on the tool stack that you pick. Which brings us to Noir, the zk language. Before we dive into the language, let's do a 5-second quick spot this difference challenge. You don't have to answer me, but can you actually spot the difference between the left side and the right being just the color? But jokes aside, left side is actually a Noir excerpt and right side is a Rust excerpt, which brings us to the killer, in my personal opinion, the killer value proposition of Noir, as well as our original intention to develop Noir, is that we think zk development should be about writing code like a developer instead of writing circuits like a cryptographer. And we believe that zk development is meant for everyone, well, except the guy in the middle of the curve, but let's take a look of what Noir itself offers then. A minor note that we are still in alpha, so syntaxes that we are seeing today could change down the road, but let's see what's available in the language. Starting off with primitive types, we have fields, we have integers, we have booleans, we have strings. Also compound types, you can define arrays, define tuples, define structs. But we also have control flows, if statements, for loops. In this example, that would be an if Boolean condition turning down into a for loop that's doing a count incrementation. And we also have operators, both comparative and bitwise. As you can see here, not equal to, as well as smaller than, comparative, bitwise and bit shifts, etc., etc. And there are a lot more features in the language itself too. To name a few, modules for you to organize your code, logging for basic debugging features, comments, well, just like any other language out there. But what's in addition to the language is also interesting. You can write tests in Noir, so instead of like learning and managing another language for tests, you can write them natively in Noir. Noir programs also comes with the capability of generating a solidity verifier for those programs, which enables you to deploy as well as like compose the verifiers on EVM chains to enable Web3 or dApp compatibility. And Noir also comes with a JS/TS package, which allows Noir developers to prove, verify, compile Noir programs in TypeScript environments, which could be very valuable if you are building, say, a browser or a dApp that requires a front-end interface. And Noir is also proving backend agnostic. What does that mean? The typical compilation pipeline of a Noir program starts with, well, developing the Noir program itself, which is then compiled to an intermediate representation, which we call ASIR, abstract circuit intermediate representation to be specific. But it can then be compiled down to different proving systems, Plonkish proving systems, NARC, Graph16, etc. So developers can actually pick their like favorite proving system or decide which of the proving systems they would like to tap into the values and advantages that they offer. Having covered like what Noir itself offers, let's take a quick glimpse of the project landscape of projects that are built on Noir. Starting off with games, we have supported the Battleships team on building an on-chain implementation of Battleships, the game, living on a public chain, but with hidden vessel information, hidden vessel positions using Noir. We are also partnering with Aragon on researching and developing a private DAO governance solution based on Ethereum storage proofs for announced DAOs specifically. But down the road, yeah, we can definitely extend that to support different DAOs. We have also been supporting Nox, a company building out a hiring platform for hiring pseudonymous talents, also using Noir. And there are a lot more different projects too. Just to name a few, there's CK Trivia, CK Capture, and there's also one guy building out a mini CK VM in Noir. Pretty cool. And what are some of the things that we might be interested in keeping an eye out for to perhaps enable you guys building out CK programs or CK projects? One of the things being recursion. So our engineering team has been taking a look into how we can enable recursion within Noir. If you're less familiar with what recursion is, you can interpret it as like a proof of proofs or down the road, folding proofs into a single proof. That feature alone unlocks like CK programs that are of infinite sizes, and or it would enable you to compress multiple proofs, aggregate multiple proofs into a single proof that you can then verify, say, on-chain. Another thing that our engineers have been heads down building with is introducing smart contract syntax in Noir, which extends Noir to not being only a proving backend agnostic language, but also a chain agnostic zk smart contract language, which theoretically can be pluggable with any programmable L1, L2s that supports private and public states. And this is actually a pretty important feature and a big unlock in our feeling point that for developing CK dApps. How so? So developing a CK dApp today starts with building out your Noir program, which you can then generate a solidity verifier for it, as I mentioned, which you can then deploy on, say, Ethereum or any EVM chains, which makes it composable with other EVM dApps out there. What's the problem or what's the caveat for this though? is that EVM doesn't understand, EVM doesn't manage private states. So if you have information to hide, say developer zkDApps today, deploying on EVMs, each of the dApp itself would actually have to manage its own private states. And if you haven't had the experience of managing like nullifiers, managing Merkle trees, I can tell you that it's definitely not an enjoyable experience, as well as it's tricky to securely implement those as well. Imagine what if a developer don't actually have to worry about writing Noir, but in addition also managing Merkle trees, sparse Merkle trees, nullifiers, solidity logic. They can just simply write a Noir smart contract more elegantly. And that's what we are extending Noir into, to be a zk smart contract language that zkDApps can actually be deployed on chains that support private and public states, where the chains can then abstract away all the Merkle tree management, storage management, just like how you develop Solidity dApps today. You don't actually have to deal with like Merkle Patricia tries, storage tries, etc. But before we wrap the sharing up, oh yes, there's a quick glimpse of the smart contract language too. You don't have to peek into it too much. Just wanted to show you that you could define like secret states. There would be contract constructor, unconstrained functions, etc., etc. More to come afterwards. But before we wrap the sharing up, one more thing. We are very proud to announce that we have completed our ultra-plonk integration literally 2 days ago within ETHTaipei. And the ultra-plonk proving system itself comes with very efficient implementation of KAKAK and ETHDSA verification, which means the integration actually unlocks developers to prove in browser KAKAK and ETHDSA. And if you are less familiar with those primitives, KAKAK, being able to prove KAKAK enables developers to build out zk programs that could benefit from very guess-efficient verification of hashes and trees. You can actually build like KAKAK trees now, and being able to prove ETHDSA verification means zk programs, zk developers could benefit from a much smoother signing experience where users can sign with their like EOAs or their MetaMask using ETHDSA signatures. But on that high note, this wraps up the quick sharing today. Feel free to scan the QR codes. The slide deck is available here. And a small tip is that you can zoom in your camera to like snipe for each of the QR codes if you guys are interested. But in the meantime, yeah, happy to answer questions if there are any from the crowd. And
any questions? No?
So I guess my question is, what's in the future for Noir? Like, what do you think it's kind of important that you want to highlight? Or I guess like how does it really put up with other, or well, I guess like what do you want it to be known for, and how does it put up with other languages? DSL, right?
Yeah, that's a very good question. Thank you for it. The vision of Noir is to be an agnostic and flexible zk language. That includes both like the traditional sense of building a zk program within it. Down the road, it will also be available despite mentioning about like extending Noir to support like smart contract. Noir itself will still stay and be improved on being a zk language that you can write off-chain apps or like non-Web3 apps using Noir. But we're also extending it to be a like chain agnostic zk smart contract language as well. So it will be the vision is for it to be the zk language that suits all the developers' needs, both Web 2 and Web 3 for zk. Yeah.
Anyone has any questions? No? Okay, let's thanks again to Savio.
Thank you.
Oh, okay, cool. Yes.